Oh, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant. And this question, no one got it right except for yours truly. And I find it to be actually not that bad. So I want to talk to you about how you would solve this one. The situation we have here is essentially that we have a 6 by 6 by 6 cube, which is volume 6 cubed, of course, or 216 cubic centimeters or cubic units, I guess it is in this case. And we're going to slice it apart, all right? This is the midpoint of this side, so this is 3 long. This is the midpoint of that side, so that's 3 long. And we slice this triangle off all the way up to here. So we take a bite out of it, right? And then we go ahead and do the same thing up here, midpoint, midpoint, slice, and we reach an area that's already been sliced, so we're basically slicing there, and slicing this bit off, right? Which is this kind of like truncated pyramid, we'll call it. So how the heck are we going to do this and do it efficiently, right? Well, first, let's think about like our strategy for a second, and I'm going to get out a nice fat orange pen like I did during the contest, and I'm going to notice that I basically am taking out, oh, and then, sorry, we also do this to each one of the edges, okay? So if we do that once, we do it 8 times. Each of the 4 vertical edges get sliced apart in this way. So notice that basically we have cut up to here and across, and then like to this here and there, and this down and across, and this dotty line that's internal, and this here, and this cut, okay? We're taking off that piece, that truncated pyramid, twice. 2 of them fit together perfectly there with no overlap, and that makes the calculations a lot easier. So if you notice that that's there, and then on top of it, you've got just a little smaller, like this one here, right? That's around this way. Can such a can't be drawn in one line like that, but anyway, like this thing here, all right? That's getting cut off too, and they meet there and they do not overlap. So if we found the volume of that, we just remove that 8 times, once per vertice of the cube going around. And there's 0 overlap between any of them because they are all cut from the midpoint. So there's like another one that's being cut over here, for example, like up to there in some weird shape. Okay, so now all we need to do is find the volume of that orange shape, multiply it by 8, and remove it. So to do this, we just need the formula for volume of a pyramid. So I'm just going to call this here point. We got G, H, A, B, C, E, F, D, G, H, I. We'll call that point J for Jennings. Okay, so that's point J. All right, and then we're going to be interested in point C as well. So what we want is, I'm going to call this like shape. So the volume of shape is equal to the volume of pyramid EFDC. I don't know why I'm popular right now. Pyramid EFDC. But then we're going to remove that pyramid on top. That's pyramid GJHC. It's looking pretty easy, isn't it? GJHC, okay? We have to take out this pyramid up here because it's not included. Okay, so let's go. Our formula for volume of a pyramid is the area of the base multiplied by the height divided by 3. Okay, so we're going to do that twice. Didn't have that memorized? Well, it's the same for a cone. Okay, if you know the volume of a cylinder that's a certain length and you put like a party hat inside, like a cone, that goes to the top, it will have 1/3 the volume. Just know this, okay? Or look it up. Or I told you during Math Mastery League these formulas in case you were missing them. Okay, so over here, the pyramid EFDC has this base, which is a 3 by 3 right triangle. So that's 3 multiplied by 3 divided by 2. And then we're going to multiply that by the height, which is 6. And then we have to divide the whole thing by 3. Okay, so that's the volume of pyramid EFDC. And then we're going to remove the top part of the pyramid. So that has, well, this is going to be half the size of the base below, okay, because it's similar. They're similar shapes, and the height is half the height. So actually, we could just scale the volume of this thing down by 1/8, but I'm not going to do that. And I'm just noticing now I can just take 7/8 of that volume. That's going to be at the bottom. Okay, let's keep going. So we have 1.5 here, and this is 1.5 as well. So we are, base times height is 1.5 times 1.5. We're going to divide that by 2, and then multiply by the height of the whole thing, which is 3, and then divide by 3. Okay, now let's do our arithmetic. It's only arithmetic now. So we have here, this is 9 divided by 2 times 6. This is equal to 9 over here. How do I know that? I divide that by 2 and get 3. I divide 3 by 3 and get that, so that's equal to 9. Okay, and then over here, the 3 cancels the 3, and that's equal to 2.25 over 2. So 9 minus 2.25 over 2 is the same thing as 15.75 over 2, which is the volume of the shape. Now, what I want is the volume of the whole remaining thing. And so the volume that's going to be remaining is equal to 6 cubed, because this thing is, 6 by 6 by 6. And being a cube, let me just cube that. So 216 minus 8 times the volume of shape, which is to say 216 minus 8 times 15.75 over 2, which is 63. Yes, that's 63. Okay, 216 minus 63. We had a calculator available, might as well check it. I mean, I think I'm kind of grossing myself out with 15.75 divided by 2, which is 7.875. Then we multiply by 8, and that gives us 63, like I told you. I'm not going to tell you how I did my arithmetic. It's a secret. I got to keep some secrets to stay ahead of students like Shariah. And so then this equals 163, and we were asked for the 2 rightmost digits, so the correct answer was 63. Any questions about this one? Hit me up in the chat. Otherwise, it was fun competing against all of you today, and I'm glad I still had something left to teach you. Okay, bye for now, everyone.